Policy-based routing or PBR. In this video, I'm going to talk about PBR or policy-based routing. First, we should understand what is the usage of the PBR, and after that, we can learn about the configuration, verification, debugging of the PBR. Okay, let's first review the concept of routing. You know that in normal IP routing, when a packet received for example, in a router, the packet's destination IP, okay, should be checked with the router's routing table. You know that every router has a routing table, and in routing table we have many routes. Okay, for example, this destination IP should check with the routing table. If a router have one specific route or default route for this destination IP, okay, can forward the traffic, and if the router doesn't find any path for this packet, the router should drop or discard the packet. Okay, this is the normal routing. In normal routing, every router only should check and look up the destination IP in the routing table. For example, the router doesn't check the source IP. The router, for example, doesn't check the protocol TCP or UDP. The router doesn't check the source IP of the packet or destination IP or for example, source port of the packet, destination port of the packet, or maybe length of the packet. Okay, router only should check the destination IP and verify and compare this destination IP with the routing table. This is normal IP forwarding or normal IP routing. Okay, you know it. But in this part, I want to talk another different method of routing. We call it PBR. What is the PBR? In some cases, in some scenarios, we need to, for example, a router use the source IP for routing. Assume that if a traffic received from a specific source IP, I need to router forward that traffic from the specific interface. Or maybe you want to send management traffic, for example, telnet traffic or SSH traffic from different interface that normal IP traffic. Let me to show you here. Look at here. In this scenario, we have R1, R2, R3, and R4. And the routing protocol that we are using in this scenario is EIGRP. And as you can see, the upper pass has bandwidth of 2 megabit per second. And the lower pass has bandwidth of 1 megabit per second. Because of that, EIGRP select the upper pass for sending traffic from the router 1 to the router 4. This means that if you check the router 1's routing table for example 10.4.0.0, okay, /24 network, the routing table contain a route for this pass, and that is the serial 10. This means that if R1 receive a traffic for 10.0 with destination IP of 10.4.0.10, the traffic should be forwarded and advertised from the, for example, serial 10. That's it. R1 doesn't check the source IP, doesn't check the content of the packet, for example, TCP or UDP protocol, or source port, destination port, length, and some other things. This is normal routing. Maybe you need, if for example, a telnet traffic received in R1, that traffic should send or forward from the lower link, because we need to send telnet or other management traffic from a path that is maybe more empty than other paths, because when the congestion is occurring in the upper link, we need to use configuration commands in R4. Because of that, it's better to use the lower link for management traffic. Okay, and because of that, when you have congestion on the upper link, you can configure R4 easily from the lower link, or some other features. Assume that we need to send the traffic of the normal data from the upper link, but because of less delay or delay intensive, for example, pass, we need for some protocols, for example, VoIP and video, that the traffic of that protocols, okay, are sent from the lower link, or many other reasons. In PBR or policy-based routing, we can configure a policy. What is the policy? In policy, you can configure rules. In rules, you can say, for example, if a packet received in R1's ETH00, please check the source IP. If the source IP is a specific IP address, it's important for you, you can use that, you can select that traffic and sending with the interface other than the best interface according to selection of EIGRP, okay? Or maybe you want to send some type of traffic, telnet, SSH, or other type of traffic from the lower link, okay? This is the policy-based routing. The policy-based routing rules is this. Look at here. Let me to show you how is the policy should be used, and after that we will learn about the configuration of policy. Look at here. We have a traffic. This packet has a destination IP. If you configure a PBR, okay, or policy-based routing, the traffic received in R1 doesn't check with the routing table at the first step. It should check with the policy. If the policy match the traffic, okay, or select the traffic should be, if the policy match means yes, the policy match, okay, then the traffic should be forwarded according to the policy. This means PBR. I will show you how you can configure policy and how you can configure the different method of routing, different interface for routing, and you will learn about that. But if the policy, okay, doesn't match, then the traffic should send to the routing table. You know that normally without the policy, the traffic normally sent to the routing table. But here we have a policy. If the policy has preference, this means that if policy match the traffic, the PBR or policy-based routing is occurring. But if the policy doesn't match the traffic goes to the or sent to the routing table, and the traffic normally forwarded. You know that if the, for example, routing table has a match for this traffic, the traffic should be normal forwarded, and here we have normal routing or normal forwarding, okay? And also if in the routing table we doesn't have any route for the traffic should be discarded, okay? So easy. And now we should first configure a simple policy and learning more about the policy and rules. But here we have a nice diagram and we can understand the rules of the policy and the action of the policy and interaction with the routing table. Don't forget, if the traffic doesn't match with the policy, okay, the traffic doesn't discard, and maybe that traffic should send to the routing table and maybe we have normal forwarding, normal routing, or maybe if we don't have routes for that traffic, the traffic should discard. Because of that, if a traffic doesn't match with the PBR, the traffic should send to the routing table, and normal forwarding can be occurred. Don't forget, the policy is not about necessarily destination IP. The policy can be about, for example, source IP, or maybe it can about destination IP, or combination of source IP and destination IP. Also, it can about the protocol, okay? And also maybe it can about source port or destination port, or for example, the length of the packet, okay? I will show you how we can configure the policy, but for now, it's better to use one simple policy because I want to show you